So the talk today is on energy efficiency best practices. This is mostly focused on commercial and public sector type facilities. There are some different things you can do in industrial type facilities as well, but our focus is mostly on commercial facilities. So kind of got an agenda of the different topics we're going to run through. A lot of this is focused on different types of what we call energy conservation measures that you can implement in your facilities and evaluate the cost benefit analysis of if savings justify making sense to make those upgrades, and try to help achieve energy goals for different types of facilities. So our primary focus at Piedmont Service Group as our core business is HVAC and controls. So we do a lot of work on HVAC and a lot of the best practices there. As far as energy efficiency, in recent years, we've had the Department of Energy 2023 efficiency increases. We've had a lot of refrigerant changes in equipment. So anytime you upgrade a piece of equipment, the newer equipment's got a lot more technological advancements, and so it's typically a lot more efficient than what's being replaced. So there's opportunity for efficiency upgrades there. Looking to upgrade air distribution. A lot of the older type systems with dual duct and multi-zone systems, we can convert those to more of a multi-zone operation with reheat that's more dedicated to specific zones rather than doing heating and cooling at the same time. Looking at things like advanced rooftop controls. So a lot of rooftop units now can come with supply fan VFD, outside air economizer, and demand control ventilation. So using CO2 to reduce the amount of outside air when it's favorable, and to increase it when there's a lot of people in a space. And Duke Energy offers a really good rebate for that particular technology. That can also be implemented on existing units as a retrofit option. There are several companies that manufacture devices that can put those three different control functions on a rooftop unit to help increase efficiency on those. Another best practice for HVAC is variable frequency drives. You can put those on fans and pumps, trying to help reduce energy using fan laws and taking a benefit of the relationship between speed and power being a cube relationship. So there's significant energy savings there. I would recommend, if you're looking to implement variable frequency drives, that you make sure that your systems are able to do that. So for instance, on the fan side, you either need to have VAV boxes that are putting static pressure feedback to the control system so that you can actually back down the speed of those fans. Or we have a lot of applications for single zone VAV where we can modulate fan speed up and down based on relationship of space temperature to set point. On the pumping side, making sure you have two-way valves throughout most of your system. You do need at least one three-way valve to make sure you get flow back to your central plant. And then we talked about conversion of multi-zone systems to VAV and the single zone VAV applications. Another HVAC best practice is using thermal storage, so you can make ice at night and then use that during the day for cooling. Usually a best application of that is based on your utility rate. So if you have a really high coincident peak demand during the day, or maybe you have an on-peak and off-peak energy rate, that you can take benefit of a lower energy rate after hours. Another HVAC best practice is looking at your building envelope. So looking at air sealing of anywhere in your building that's leaking, making sure that you're not losing air to the outside and then drawing that back in for additional energy consumption there. Looking at insulation and other different types of building structures that can reduce your energy consumption and the load on the HVAC system. On thermal storage side and the building envelope side, this may also help you to reduce the size of your systems and reduce that upfront cost for system upgrades. One of the other big pushes we see on the HVAC side in more recent years is a push for decarbonization. So trying to convert systems from natural gas over to electric, going from gas to heat pumps in a lot of cases. Just want to make sure you're really careful with that and make sure that you have the electrical infrastructure in place to make those changes as you're converting from one fuel source to another. On the building automation side, ASHRAE published a guideline 36 a couple years ago that gives a good general guideline of different best energy efficient practices for building control sequences of operation. those are a great starting point, and then you can kind of modify those as you need to fit what the needs are of your particular building. Another best practice that we try to implement everywhere we can, where you don't have a 24/7 operation, is occupancy scheduling. So you only want to schedule your HVAC systems to be in operation when there are people in the building. But you do want to be careful with that too, and making sure that you're using some kind of optimization sequence, or maybe turning the systems on early to make sure that buildings are at set point by the time people arrive. Looking at things like temperature and pressure resets. So you can reset temperatures on your discharge air temperature, so you're not cooling air all the way down to 55 in the middle of the winter and then heating it back up to maintain space temperature out in your different zones in your building. And then looking at pressure resets, so that depending on where your VAV boxes are, you may be able to further reduce your fan speed and reduce your energy consumption there. A big topic of conversation in recent years on the building automation side is outside air control. In a lot of cases, try to use outside air economizer for free cooling whenever you can, when outside air conditions are favorable. And then you can look at doing demand control ventilation using CO2 sensors to reduce the amount of outside air down to the ASHRAE 62.1 minimum area flow rate. You do need to make sure you at least maintain that, but you can reduce the people flow rate when the CO2 levels are good. But you do have to be careful. If you open up the outside air too much with CO2, your system may not be able to handle the amount of load that the additional outside air puts on it, depending on how it was designed. And then I know there's a lot of push during COVID to move as much outside air as possible. So being really careful with that as well, making sure you're not, especially in this part of the country, not winding up with humidity problems and other unintended consequences of how you're controlling your outside air. Another BAS best practice that is a good low-cost thing to do is retro commission your buildings. Over time, we know our buildings drift a lot from their original intended control sequences and where they were originally commissioned, as people operate the buildings over time. So going back and verifying the systems are operating as they should be, and trying to make sure that there aren't overrides in place and things that may be keeping you from optimizing your energy efficiency. Another thing that's came out in recent years that's really helping on the control side is using analytics for fault detection and diagnostics. So you can review the trend data from your BAS with multiple variables at one time to optimize your energy consuming systems for a more proactive approach. So you can look at different variables that can tell you things that a normal building automation system alarm may not tell you. Typical alarm is just going to tell you if a system's down and it's not operating, or maybe one parameter is out of the tolerance that it should be. In this case, you can look for things like simultaneous heating and cooling, building systems operating when they shouldn't be, dampers stuck open, reheat valves stuck open, and a lot of different things that you normally wouldn't catch with that allow, and it also allows our technicians to be more proactive in the field when they're diagnosing issues and trying to solve problems and create solutions for getting systems back up and running more quickly. So you can use the data review to direct your maintenance activity and your energy efficiency upgrades. You may see some things that you didn't see before, and you can help make changes to the system to increase that energy efficiency. So some other areas that we've worked in, we are a certified energy services company with the state of North Carolina, and so we do some performance contracting. So some other areas where we look at energy efficiency when we're looking at a building as a whole includes lighting and electrical systems. So you can upgrade your lighting systems to LED. We kind of went through a couple of cycles now with going from T12s to T8s and now to LED. A lot of benefits of going to LED. There's a lot of different color options and applications you can do. The LEDs don't have the restrike that the ballast had on the old HID lights. So there's a lot of operational benefits as well, and maintenance benefits. A lot of cases the LEDs last a lot longer than the older technologies. Another best practice is to implement occupancy sensors and lighting controls on the building, and so those sensors, a lot of cases, can be tied to the building automation system to help tell the system to maybe go into a setback temperature for additional energy savings on your HVAC system. Putting overall controls on the building from the BAS so you can schedule your lights on a similar schedule to your HVAC system. And then you can use that trend data with the fault detection and diagnostics as well to monitor and control your lighting and make sure that in a lot of cases you're not having someone come in, someone's coming in after hours. You're able to figure out why that's happening and why it's causing your lights to maybe run more than they should be. Another technology we implement is daylight harvesting. So there's sensors that can be installed that help dim lights during the day or even turn them off when there's enough daylight present to illuminate the room and reduce energy consumption there. We've implemented some smart transformers that have lower losses than traditional transformers. Plug load controls are something you can implement to make sure that different plug loads in the building are turning off during unoccupied hours as they should be. And then there's different computer power management softwares that can be implemented to reduce energy consumption in computer labs. Moving over to water system best practices. So we look at upgrading plumbing fixtures. This could be aerators, shower heads. Toilets can either be replaced or they can be retro commissioned back to their original flow ratings to save water. Upgrades to domestic water heaters. So looking at going to tankless systems that are a lot higher efficiency and don't have the standby losses of tank type systems. Some other technologies that we've implemented. VFDs on pool pumps. We did find on a recent project that we've got to be really careful with that right now because there have been some code changes that require GFCIs that are not compatible with some VFDs. So making sure you're paying, as you're going through your development process, just keep an eye on the codes and making sure everyone's on board with what's being done there and that the local jurisdiction doesn't have any problems with the different technologies you're implementing. One unique energy conservation measure we implemented as one of our recent performance contracts was pool chemical generation. So instead of buying chlorine, they use a salt generator on site to generate chlorine, and that significantly reduces operational costs from the reduced cost of the salt versus the chlorine. There's a little bit of an energy penalty of generating salt on site, but there's additional energy benefit because a lot of cases you have to do additional water dilution if you're using purchased chlorine. And so there's some energy benefit and some water benefit on that side. So there's also a lot of renewable technologies out there. As part of my background coming from the IEC and then working on the energy efficiency side of things, we try to promote energy efficiency first and reduce and make our buildings as energy efficient as possible up front, and then try to focus on what renewable technologies we can implement to try to help with energy efficiency and try and potentially also that decarbonization effort. One of the technologies you can implement is solar PV and domestic hot water. We finally got our first solar PV project done as part of that most recent performance contract. Duke Energy's got some good rebate programs right now that help support that and help to make that piece of that project cash flow. I've looked at wind a little bit in the past, but typically small scale wind doesn't have a really good payback. So it usually needs to be done on a much larger scale, and the wind in this part of the country is not really conducive to as much wind opportunity, but there are some places where it makes sense. Biofuels and there's renewable natural gas that's being developed a lot in eastern North Carolina. Technology for geothermal, hydropower, and hydrogen. There are a lot of great resources to help renewable technologies. I know North Carolina Sustainable Energy Association is a good place to go if you need some assistance with looking at opportunities for renewables. So coming from the contracting side, I know there's always a lot of questions about current cost environment. So on our side, we see costs continuing to rise, but not nearly at the level we were seeing in 2021 and 2022 when we were seeing price increases almost every month. It's kind of went back down to more of a yearly price increase on most things at this point. Big thing we run into right now is lead time of equipment and getting equipment here and to be able to get it installed. Finance projects are still struggling a little bit with the higher interest rates, and it doesn't look like those are going to be going down anytime soon. Um, there are alternate funding sources that are available or were available in recent years. The Inflation Reduction Act put a lot of investment into energy efficiency projects. Duke's got some really good rebate programs, and I suggest if you're on local utility or local co-op, at least reach out to them and see if there's potential for rebate programs. Some have been open to pilot programs in the past, and some not as much. We had the ESSER funded projects that were coming through, looking at using 179D as a tax deduction option for implementation of energy efficiency projects. There's a REAP program for rural projects that can help get some grant money to help support energy efficiency projects there, and a lot of other different ways to fund those projects. I think a big thing with the current cost environment, there's a lot of unknowns with the upcoming changes. There's a lot of funding going or freezes going on with federal funding, and we're trying to learn what direction all of that's going. But I think there's always going to be a lot of effort behind doing energy efficiency projects and helping fund those, and then making sure you're doing your capital planning and budgeting and trying to use energy efficiency and the savings potential there to help push the effort to get those projects completed and help go toward those goals. So that's general topics that I have. Are there any questions?
Thank you, Dale, so much for this presentation. Let's check if we have some questions from our audience. Really quick. I see a few things in the chat. Beyond electrification, what are some innovative strategies for decarbonizing HVAC systems?
That's a good question. So trying to think about decarbonization. I'd say looking at some of those alternative energy sources is a good way to decarbonize. But yeah, electrification is a big way, and then trying to find renewable ways to support that electrification, I think, is most of the way to get there. I know there was some talk about potentially for base load, looking at nuclear at the AE World conference last year. So there's that, along with the solar and wind and geothermal and everything else we can try to do on the side of decarbonization. And I think the biggest thing to decarbonize is the energy efficiency side, and trying to reduce the energy consumption and reducing waste everywhere that you can.
Thank you, Dale. I see another question here from Scott Pfister. It says, I'm aware of heat pumped water heaters for residential. I have one at home, but I haven't heard of commercial or industrial scale. Any leads?
That's a good question. I'm not aware of any industrial scale water heat pump water heaters at this point. Yeah, I think that's a big question going forward with the decarbonization side, is how, that's one of the best ways to convert natural gas water heating over to electric. I think in a lot of cases the residential technologies kind of come out first, and then the commercial kind of follows suit. And so hopefully we'll see a technology that's comparable on a commercial scale in upcoming years.
So he's also asking, are there any lighting technologies that aid in transitioning a multi-shift building to help employees, specifically third shift acclimate?
Is that some? I'm trying to think. Is that looking at like transition, since they're coming in third shift at night versus coming in during the day with?
Can perhaps Scott unmute and maybe clarify the question?
Sure, no problem. So I was just thinking more like the color spectrum or dimming, or I've never worked third shift, but I could imagine going from daylight. Our brain is naturally acclimated
Yeah.
to certain color spectrum, or dark in the morning, dark in the evening, but on third shift
Okay.
it's dark the whole time. So
Yeah. Yeah, I think with LEDs, there's pretty endless possibilities with what you can do with the lighting and sensors and trying to or controls and trying to change that. It just depends on how much, like at the end of the day, it ends up being how much additional cost is there to that, and is that cost worth the benefit?
I hope that answered the question. If you want
Yeah.
to ask something else, please feel free to elaborate more. We still have good time for more questions. Okay, I see a couple questions here in the chat. What kind of software do you use?
For energy efficiency calculations, is that?
Jacob, if you can unmute yourself and maybe clarify what kind of software you might be referring to.
I can speak to energy efficiency calculations. So it really depends on what level of project we're looking at. If we're doing just a simple basic ASHRAE level 1 type audit, maybe even a level 2, we'll do a lot of spreadsheet calculations. Duke Energy has some really good smart saver tools they use for their rebate program that can do some energy efficiency calculations for you. You can ask your account manager for access. They should be able to give you a login, or if you're working with a contractor, they should have access to run some quick, easy efficiency calculations to determine estimated energy savings. And they can also produce how much of a rebate potential there is with that project. And so that makes it really easy to submit for rebate applications. If we're going up to more of an ASHRAE level 3, like an investment grade energy audit for performance contract, we've typically worked with some third party engineers that use TrainTrace or CareHap. I know some use eQuest. So there are a lot of softwares out there that you can use to calculate energy savings for your projects.
Thank you. I see another question here. What are the most common barriers or challenges organizations face when trying to implement HVAC best practices, and how can they overcome them?
I mean, I think funding's always a challenge, making sure projects can have funding in place. But I think internally within the facility, it's getting everyone on board with why we're making the changes we're making. So a lot of cases, there's a lot of resistance to changes, and how running equipment all the time. I've heard people say, well, if we turn something off, it'll never turn back on, or someone wants their space to be 62 degrees in the middle of the summer or 80 degrees in the middle of the winter. Um, Depending on how a building's laid out, you may have 4 offices sharing one thermostat, and getting all 4 of those folks on board with a common control strategy can be a challenge. Um, Running into limitations with what a system can do. If a lot of times on our performance contracting projects, we're kind of limited by how much energy savings can fund. And so there's only so many things we can do with a system in that case to try to optimize it on the energy side and keep people comfortable. I think the balance between energy efficiency and comfort is always the biggest challenge. We want to make sure we keep everybody comfortable.
Thank you. Let's see if we have another question here. Just see a comment, technician training, having them involved in beginning as well as install O+M training from vendor. I think that's adding more to that, what you were explaining.
Yeah, yeah, for sure. Definitely, your contractors and your energy efficiency folks are making these recommendations. Definitely need to be in sync with the teams that are implementing them and making sure what is proposed can be implemented. And then once implemented is operating as it's intended to, and making sure everybody's on the same page from the beginning is definitely critical.
I see another question here. Is there a set of indicators or a monitoring system that can help determine the optimal time for recommissioning an HVAC system?
So as far as optimal timing is and how often you should do it, or predictive, because I think if you've got a lot of the analytics technologies that are out there now kind of allow you to do that retro commissioning continuously, which is really beneficial, so that you're continuously monitoring those systems and making those changes and improving them instead of coming in every couple of years when something might have been changed not long after you first implemented it, then it's been sitting there running that way for an extended period of time. In a lot of cases, the analytics softwares lay on top of an existing control system, and there's not a significant amount of cost to them. There is some training and learning, a little bit of a learning curve, making sure everyone understands, what they're looking at, how to interpret those systems, and then how to turn it into actionable items.
The same person says yes. How often? I think that's what he was trying to ask.
You can set a schedule of every couple of years if you're not using an analytics software. I think your first indicator of if things are starting to get out of control are utility bills. Are your utility bills starting to creep up? That's usually a good indicator that, hey, it might be a good time to go and retro commission our systems and make sure we're not losing energy.
Is there any other question from the audience? We still have some time for questions. Please feel free to put them in the chat. I can read them to Dale and then discuss. So I don't see any other questions in the chat. So, well, I guess if later on they have questions, maybe they can reach out to the center
feel free.
or you.
Yeah, feel free to reach out, and if I don't know the answer, I've got a lot of resources. We can find somebody who does. So
wonderful. Okay, well, I guess we'll wrap up this session for today. Dale, can you move the slide? Oh, Pablo is leaving your email in the chat for those interested in connecting with him and maybe ask questions if you have one later on. Just want to highlight this event that we have. Actually, the previous webinar, we have promoted a webinar with an EPA engineer. This was going to be about oil and gas, but unfortunately we had to cancel this event. So in her place, we're going to have a professor from Oregon State University that's going to be speaking about PFAS, forever chemicals. And if this is something you're interested, please join us in the next session in March. It's going to be March 24 instead, and you will be receiving an invitation alongside the presentation from today. Next slide, please. And for those that might be close to us, we have an upcoming workshop about pollution prevention strategies for manufacturers. This time we're going to be in Washington, North Carolina. The venue is actually the Harbor District. We had a slight change there. But the date is the same, February 27, and you are welcome also to join us. You will receive an invitation for that event as well in your emails. And next slide, please. And that's it for today. We're going to give you back 20 minutes, I believe. But we truly appreciate everyone's attention today, supporting us in our mission to promote pollution prevention and source reduction. Please stay informed with our events. We have a newsletter. We also are constantly working on our website and information on LinkedIn. You can find us there. Also, please feel free to reach out via email if you have any question or would like to receive any of the services that we explained earlier today. Thank you so much. Thank you, Dale, for presenting today, and I hope we can stay in touch for future collaboration.
Yeah, you're welcome. Feel free to reach out anytime.
Wonderful. Have a great rest of the day. Thank you.
You too. Thank you.
Bye-bye.